Chapter 11 deals with series, both arithmetic and geometric series, and you really just need to know 4 equations for all of these to work out. If you have an arithmetic one, that's where a series like 3, -1, -5, where you're adding something to get to the next term, in this case a -4, that's where you find the arithmetic ones. A geometric series is something like 4, 20, 100, where you're multiplying by 5 to get to the next term, or multiplying by something. So here you're subtracting 4. Here you're multiplying by 5 to get to the next term. Anytime you're adding or subtracting, you use either of these two to find the next term of something. In all cases, all of these are going to equal, if a sub n is going to equal the nth term. A sub 1 always equals the first term. Anywhere where you see a d, that is the difference between two terms. And that is only found in the arithmetic series between one term and the next term, I should say. And then anywhere where you see an r, that is the multiplier to get to the next term. N is going to equal the number term that you're looking for. So like the 50th term or the 16th term. Not what the term is, just what number that is. And you'll see that here, and you'll see that here. So to find sum of this, for example, here, let's say that you're trying to find the 8th term of the series. So you know that the multiplier is 5, so a sub n is going to equal a sub 1, which is 4, that's the first term, times 5 is the multiplier, n minus 1 is the 8th term is what I'm looking for, so 8 minus 1, so a sub 8 is going to equal 4 times 5 to the 7th, which equals 4 times 7, 8, 1, 2, 5, which is going to equal 31,250. So that's what a sub 8. So if you're trying to find the sum of the first 9 terms of the series, I'm going to go look at this equation right here. S sub n, my a sub 1 is again going to be 4. This is going to be 1 minus r, again, is 5 to the 9th power. That's the 9th term of the series, over 1 minus 5. 5 to the 9th power is 1953125, and if I subtract that from 1, I get 4 times negative 1953124, all over a negative 4. Multiplying that by 4 and dividing by a negative 4, because those 4's really cancel out, it's just going to make itself the same. So that's positive 1953124, and that's the sum of the first 9 terms of the series. For the arithmetic series, I'm going to use this equation up here to find the 12th term of this particular sequence. I know that my a sub 1, so I'm looking for the 12th term, my a sub 1 is 3. My d is a negative 4 because I'm changing 4 between each series, or between each term, and my n, I'm looking for the 12th term, so it's just 12 minus 1, so 3 plus a negative 4 times an 11, so that's 3 times, or minus 44, which is a negative 41. That's the 12th, term of my series, and to find the sum of the first 15 terms of my series, that's s sub n equals, so number of terms is 15 over 2, first term is 3, my last term, I don't really know what it is yet, so I have to figure that out. So I'm going to go over here and say, what is my 15th term? Well, same way that I did it on top. So I'll have 15 minus 1, so that's 3 plus negative 4 times 14, which makes negative 56, which will be negative 53 here. So coming back up to this part, I'm going to say it's 3 plus a negative 53, or 15 over 2 times 3 minus 53 is 50. Canceling these, I get 20. That's 375. Last part of this chapter deals with sigmas. These sigmas mean sum of all terms. So this means take the sum of all terms from the start, which in this case is 1, to the end term. So not 6 terms after the first one, even though in this case it is. It's the 6th term. So what you do is you take this, which is going to be equal to 3 times 1 minus 1, plus, because it's sum, 3 times 2 minus 1, plus 3 times 3 minus 1, plus 3 times 4 minus 1, and so on. And in this case, 3 minus 1 is 2, 6 minus 1 is 5, 9 minus 1 is 8, 12 minus 1 is 11, 15 minus 1 is 14, and 18 minus 1 is 17. So adding all of these together, 57. That's the sum of all of my terms. Last topics is the trig. If you have a right triangle and you have a right angle here, this angle which we call theta, let's say I give you this is 27. From this angle, you just look from this direction. So let's say you're a person and you're looking at this. Well, the opposite is going to be over here. The one that's next to you as a person is the adjacent, and the long side is always the hypotenuse. And you just need to remember so, ka, toa, where S, the sine of theta, or 27, is the opposite over the hypotenuse. Ka is the cosine of theta, which is the adjacent over the hypotenuse. And toa would be the tangent, which is opposite over adjacent. And using these, as long as you know what ratios there are, if I give you an angle and I give you the opposite angle, you just need to solve for one of these. So let's say here's 27. Opposite, I give you 8. And what is my hypotenuse? Well, I'm going to look at these. Which one deals with opposite and hypotenuse? Because I want to know what this is. Well, the sine does. So sine of 27 equals my opposite, which is 8, over my hypotenuse, which is something I don't know. So I just need to solve for this, multiplying both sides by x and dividing by sine over 27. I just do 8 divided by sine of 27, making sure that I am in radian mode. I'm sorry, degree mode. So 8 divided by sine of 27 is 17.62, which is what equals my adjacent side. All right, that's it. Good luck on your final.